Hi dear learner, welcome. Today's topic is present value of a single cash flow. In previous topic, we have seen how to find the future value of a present cash flow using the formula. We can actually use the same formula after some rearrangement to find out the present value of a future single cash flow. So let's start, dear learner. At first, the notations are the same. I just want you to recall that we have used R to indicate the compound interest rate and N to indicate the number of years, PV for present value and FVN for future value in N years. So previously we did not know what is the FV, okay, and we used the PV, N and R, these three, to find out the FVN. But now we do not know PV, okay, we will use the other three, R, N and FVN, to find the PV. So if you can recall that the future value after N year was expressed like this: FVN is equals to PV times 1 plus R to the power N. We can rearrange this equation to find the expression for PV. Okay, so what we can do is we can divide both right hand side and left hand side by 1 plus R to the power N. Okay, so if we divide both sides by 1 plus R to the power N, then we get PV is equals to FVN over 1 plus R to the power N. So this can be the expression for finding the present value. We do not need to do any, we do not need to go for any detailed illustration like before. Okay, so let us try to visualize this formula using the cash flow timeline. So in this case, we do not know what is PV. We do not know that, but we know what is the future value after N years. Okay, so according to this formula, what we will do is we will divide the future value after N year by 1 plus R to the power N to find the present value. So you can see that the amount will be less. The future value will be reduced to some certain amount to get the present value, and it will be done by dividing the future value by 1 plus R to the power N. So this process is called discounting. This process is called discounting, which is opposite to the compounding. This is why sometimes we call the compound interest rate by discount rate. Okay, so sometimes we do not use the term interest rate, rather we use discount rate, but we can use these two alternatively, no problem with that. Now let us try to see an example, very simple example to example of finding the present value using this formula. So let's say that the future value in 2 years is given $121. The interest rate or discount rate is 10%. Okay, now you have to find what is the present value. Unlike the future value, present value does not have any n, because you know that present is always time zero, that means year zero. Okay, as we have seen in one of the lecture where we have explained the cash flow timeline. Okay, so our formula is given here. Present value is equals to future value after N year over 1 plus R to the power N. So in this case, let us plug in the values in the formula. Present value is equals to future value after 2 years is $121. Okay, $121, and we know that the discount rate is 10%, which is 0.10 in decimal format. Okay, and the exponent should be n, that means in this case it is 2 years. Okay, so if you use your calculator to find the result, then you will see that the result is 100. Okay, so 100 is the present value. Now if we try to visualize again this case using a cash flow timeline, we can see that after 2 years we have the future value of $121. So now what we are doing, we are actually discounting it for 2 years, okay, using the present value formula. Okay, and after doing that, we have found that the present value, that means the value of this $121 after 2 years at present is 100. Okay, so In other words, if I want to explain that you will be indifferent between getting $100 today and $121 after 2 years if your compensation rate or interest rate or discount rate is 10%. I hope that you have understood how to find the present value of a future amount of money or future amount of cash flow. Thank you for attending this session. Hope to see you again.